Welcome back. Day one of quadratics. Two big topics here: U substitution, which was video number one, and completing the square, which is this video. So completing the square is another way to solve these things without some things, excuse me, sometimes we can't factor these things very well, and so we complete the square instead, because factoring only works for our purposes when the factors are rational numbers. So we're going to look at this way to do it. So here's another way to solve these things. Basically, the way that we're going to solve these is by taking square roots. This idea, if x squared equals k or something, some number, then x equals plus or minus root k. Like basically what I'm saying is if I start with x squared equals k, I can do square roots of both sides, and I get this expression. So that's how we're going to do a bunch of these, and we're going to see a way to do how to get it to look in. I'm just going to start because I'm having trouble talking. So we're going to add 4 to both sides of this one. And we get x squared equals 4. Then we take square roots of both sides, which means x equals plus or minus 2. And I want you all to just get your heads around the idea that the square root of x squared is equal to x. It's technically equal to the absolute value of x, but we're going to take care of that by doing the plus or minus over here. So let's just think of it for now that the square root of x squared is x. And if you do whatever's on the other side, you better put a plus or minus in front of it, or else you're doing it wrong. So that's fine. That was kind of an easy one. You might even have been able to look at this original thing and be like, 2 clearly works. 2 squared is 4, and 4 minus 4 is 0. Or you might have thought, well, if 2 works, then negative 2 must also work, because if I square a negative, I get a positive, and those are the 2 answers I got. This one may be less obvious. You might be like, well, what do I square to get 16? Well, 4. So x equals 2 should be an answer here. But there's another answer, because there's 2 things you can square to give you 16, 4 and negative 4. So to get negative 4 in here, I'd have to have a different number for x, but that's not how we're going to do it. But it's just you might be like, well, x equals 2 is for sure going to work. And I think x equals negative 6, because negative 6 plus 2 is negative 4. And negative 4 squared is also 16. So this is my guess. It's not really a guess because I know it works, but we're going to solve it the other way anyway. So the way we solve this, the current way, is we're going to do square roots of both sides. So square root of x plus 2 squared is going to be x plus 2. And the square root of 16 is going to be positive or negative 4. And this is great, but I want to know what x is. So I'm going to get x by itself by subtracting 2 from both sides. And I'm going to write the negative 2 first, because that's kind of typical. If I do minus 2 on both sides, I get x equals negative 2 plus or minus 4, which looks like, it doesn't really look like 1. This is actually equal to 2 numbers. This is either x equals negative 2 plus 4 or x equals negative 2 minus 4. So if x equals negative 2 plus 4, then x equals positive 2, which was one of my guesses. What do you know? X equals negative 2 minus 4. That means x equals negative 6, which was my other guess. What do you know? So this is another way to solve these things. You have something squared with an x in it, you can take the square root of both sides. Like I said before, the basic idea here is this. We're going to take the square, get something squared equals a number, and then we're going to take the square root of both sides. So I'm not really sure why this one's here, but if you factored this one, you would get this. And we can write this like x minus 5 squared equals 0. Now I can do roots of both sides. This gives me x, oh, what's that in red again? This gives me x minus 5 equals 0, which means x equals 5. It's like plus or minus 0, but that doesn't really change. 0 is the one number in the world that's neither positive nor negative. So plus or minus 0 doesn't really make any sense. So that wasn't that hard. We basically just used factoring for that one. But at the end, I was like, let's think about this taking square roots of both sides idea, which we did because this turned out to be something squared. And for this one, if you factored this left side, you would get x minus 3 squared equals 7. Actually, let me say this before we move on. So you might see this, a reasonable thing would be like, well, we did this a bunch of times where we were like, if we have x squared, we'd move the 7 over, get one side equal to 0. So you subtract 7 from both sides and you get x squared minus 6x plus 2 equals 0. But like this can't be factored. And that's why we want to do it this other way. There are no factors of 2 that add up to negative 6. Just doesn't work. So this is like a no-go. That looks like a x, like it's like an xx. Let me do. No, that doesn't work. So instead, if we look at it like this, you can factor the left side. It's x minus 3 times x minus 3. And now we're in the situation we're in up here where we can take the square root of both sides. And we get x minus 3 on the left and plus or minus root 7 on the right. Now I'm going to add 3 to both sides. And I get x equals 3 plus or minus root 7. And this is the answer. This is the solution to this equation, the solutions, I should say. You can see that there's no way you were going to get those things if you were factoring. So this is why this is a good trick sometimes, because you can't factor all of them. Like this one you could factor and it was great, and we could have been like, from this step, we could have said x equals 5. I went ahead and wrote it as something squared equals a number and then took the square root just to demonstrate how these two are similar. This one, you didn't need to do it. This one, you did. And now here's like kind of the generic idea. So I look at this, the first thing you should always try and do is factor. And I look and I'm like, are there any factors of 2 that add up to 2? The answer is no. It either adds up to positive 3 or negative 3. So this is a no-go for the factoring. Can't factor. So I'm going to do this trick where I write it as something squared first. So here's what we're going to do. So step 1, there's these steps here. And I'm just going to run through them with this example, and then I'll do another one in class. It's going to be, this is the thing, this is probably the hardest kind of solving that there is with these. So first thing I'm going to do is I'm going to move the constant term, assuming that there is one, which there is here, to the right side of the equation. I'm going to leave a little space here. So the first thing I did was I subtracted 2 from both sides. Get the constant over here. And now in my little thought bubble over here, because this is not really part of a solution, I'm going to do this. I'm going to look at the middle term, but really it's just the coefficient of the middle term. That's plus 2, a positive 2. What I'm going to do with that positive 2 is I'm going to divide it by 2. So I do the positive 2 divided by 2, and that equals 1. Okay, and that's like step, well, I didn't do this step, but the A was 1. So add half the linear terms coefficient to both sides and square it. That's a confusing way to say that. That's really not how you're supposed to do it. I'm gonna have to rewrite those directions so they're better. So I take this thing and I divide it by 1. Sorry, excuse me. I take the middle term here, I divide it by 2, and I get 1. And then I square that number. In this case, it happens to stay the same because 1 squared is 1, but if it was 4 over 2 and it was 2, then this would be 4. And if it was 8 over 2, that square gets 16. But you divide this middle term here, the coefficient of this number, you divide by 2 and you get 1. And then you square that and you also get 1. And then I add this thing to both sides. The squared part is what I add to both sides. So I get x squared plus 2x plus 1. I don't know why I wrote that again. I left myself a space and everything. It was negative 2 plus 1. Now I have x squared plus 2x plus 1 equals negative 1. That's annoying. That's fine. And now my claim is now that this is a perfect square. I'll write it a little better. This can be factored into a perfect square. This is what I mean. What I mean is if I factor this left side now, I get x plus 1 times x plus 1 equals -1, which means x plus 1 squared is -1. And now I'm kind of in business because now this looks like this setup where I have x plus or minus something squared equals a number. So I do the same trick here that I did there, which is that I take square roots of both sides. Now I get this side becomes x plus 1. And this side, as we learned in the last unit, becomes plus or minus I. Now I subtract 1 from both sides and I get x equals -1 plus or minus I. So my plan with these is to like spend our next class talking about, do like a couple examples of U substitution and do a couple examples of this and then let you guys get to work. I know that this is a kind of a confusing process, but the more you do it, the easier it will become. So here's completing the square in 5 easy steps, which I just did. Move the constant term to the right side. That was moving this positive 2 to the right and making it -2. And it said if a is not 1, divide everything by a. That means if there's a number in front of x squared, divide everything by that first before you do anything else. And here, there was no number in front of x squared. It was just 1. You can see here a, b, c, and d. Now I promised I would rewrite this, and I will. Add half the square of the linear terms coefficient to both sides. And that was when I took this number in the middle. This term here, the 2x, is the linear term. It's x to the first. You take that number, that coefficient, you divide it by 2, and then you square it. That's what I did there. This would be, if you're looking at this as your kind of like generic example of a quadratic, ax squared plus bx plus c equals d, this would be b over 2 squared. So basically you take the middle thing, divide it by 2 and square it. Then you can factor the left side as the square of a binomial. That was factoring this thing into x plus 1 squared. And then complete the solution by solving for x. And that was when you take the square roots, which is what I did here. So these are the steps for completing the square. Works every time. Like I said, I'll do some more examples in class. So thanks for listening. Bye.